About the building blocks of geometry. So points, lines, angles, and planes are what we're going to use to build all the other figures in geometry. The person who started modern geometry really thought kind of the same way. He started with some very simple ideas and then built out the rest of geometry just based on that. His name was Euclid. He was a Greek mathematician from about 300 BC, so about 2,000 years ago. And he started with just a simple set of definitions, followed the logical implications of these definitions, and then came up with a bunch of properties based off of that about all these different shapes, triangles, rectangles, circles, all of that derived from these very simple definitions that he called postulates. And you could look at these. You don't have to know these, but they're really, really simple. Drawing a straight line between 2 points. A circle has a center and a radius. We can draw a line indefinitely in either direction. These are really simple ideas, but just from these, the logical implications from them, we are able to decide a lot of properties about everything that exists in geometry. He wrote a book called The Elements. So on the left side, you see the table of contents for that book. When he uses the word book here, he actually really is describing chapters to us. So each chapter is just describing a different figure, or sometimes even pretty complicated math. But it all started with just a simple set of 5 postulates. Over 2,000 years, it was completed and made into a consistent system that we call modern geometry. All right, so each of these is really just going to be a term, and then some notes about that term or an example of how to write it. Our first term is a point. So a point is a location in space. So when we graph a point on a coordinate plane, if I say the point 5, negative 6, and I draw that dot, that represents a point in space, an actual location, not the actual dot itself. Because the dot has a size and a shape, but a point in the math sense does not have a size or a shape. It is just labeling a location in space. We could call it point A by writing that out, or simply just the letter A. A line is made up of infinitely many points. Any 2 points can form a line. And a line is infinitely long, but it has no width or depth. A line has 1 dimension, just length. A point has 0 dimensions. We could label this line as line N. We see that lowercase letter right next to the line. It's not next to a point. It's just labeling the line. Or we can label it by its points. So we have the points X and Y. You write out both X and Y, and then you write a double-sided arrow over top of that. It's saying it goes on forever in either direction over the points X and Y. We could also flip that. The order really doesn't matter, but you need that symbol on top. X and Y are called collinear points. They are points that are on the same line. Co means together. Linear means line. They are together on a line. Array is also one-dimensional. It's continuous in just one direction. So it has an endpoint and then continues off indefinitely in one direction. Same kind of notation, except there's only one arrow. So X then Y, or Y then X. But since we have an endpoint, we don't draw the arrow on both sides. We just draw it on one side. A line segment is a continuous set of points with 2 endpoints. Here, that's marked as P and Q. A line segment has a length, but no width or depth. A line doesn't have a specific length. It goes on infinitely long. A line segment has a specific length. It ends. Similar notation, P then Q, but no arrows over top, or Q then P, no arrows because it ends. When we measure a segment, we're talking about the length or the distance from one point to the next. So that's 1, 2, 3, 4. That has a length of 4. It can be written as the length of, here we're talking about AB, or just AB. We could say AB is 4, and that's talking about the length of AB. All right, a plane is a two-dimensional shape. It has a length and a width, does not have a depth. It doesn't go, doesn't go into the paper. A plane is a flat surface made up of points. Any 3 points make up a plane, and a plane extends indefinitely in all directions. Obviously, we can't draw this on the paper, but this goes forever in all directions. Even if it's not drawn that way, that extends forever in every direction. So you can see we have 4 letters on there. 3 of these represent points. We could say that is plane K, J, or let's keep it in alphabetical order. Let's say it's plane J, K, L. The order really doesn't matter. You could say L, J, K, as long as you include those 3 letters. Or there's a letter on the side here that's not associated with a point. That's talking about the plane. We could also call this plane P. Points that are on the same plane are called coplanar. Again, that prefix means together. They're together on the same plane. Intersecting lines. 2 lines that hit each other intersect at a point. When we have 2 planes that hit each other, this is a vertical plane, this one is horizontal. When they hit, they're hitting at a line. Their intersection is a line. All right, you should be able to try each of these on your own. As people were practicing, these last 3 were the trickiest section. I'm just going to talk about those real quick. The intersection of plane R and plane Z, V, Y. This triangle. You want to think about where this plane intersects with the plane on the bottom. It's this line here. They're connecting at all of those points in that line, a really line segment. That's VY. The next thing I kind of just want to clarify here, when we talk about this square in the middle of that pyramid, that's a part of plane R. That's not a separate plane to itself. That's already a part of plane R, so that's included in that. All right, congruent segments. Congruent in geometry means that they're equal. We use the word congruent when we're talking about figures. We use the word equal when we're talking about numbers. So if I say that triangles are the same size, I could say that they're congruent. If I say that 3 equals 2 plus 1, I use the word equals because I'm talking about numbers there. So equal applies to numbers, congruent applies to figures. So if AB equals CD, that's talking about the length of those 2. That has a length of 4, that has a length of 4, then the segments are called congruent. This is written as AB, sorry, I should have the segments over top, is congruent to CD. So you put a tilde above an equal sign, and that's saying that these 2 figures are congruent. Segment addition postulate says that we can put 2 segments together to form a longer segment. If A, B, and C are collinear, they're all on the same line, and B is in between A and C, then AB plus BC equals AC. That plus that equals the whole length. Midpoint It's pretty much in the name. It's the middle point. Midpoint of a segment is a point that divides the segment into two congruent segments. These are marked as congruent. This is showing that AB is congruent to AC. That mark and that mark are saying that these are the same. If you put 2 marks on something and 2 marks on another thing, that's saying that those are the same. So the number of markings indicates whether they're the same or not. A line, ray, or segment that intersects a segment at its midpoint is called a bisector of that segment. It's the same idea. It's splitting it into 2 congruent parts. This is a bisector. It's splitting this line AC, line segment AC, directly in half. So in the diagram, B is called the midpoint. That's the point in the middle of AC. And the line L is a segment bisector. Bi means 2. It splits it into 2 equal sections. That's what bisector really means. It's a segment bisector of AC because it connects at that midpoint. Four was the challenging question here. I think you could do the other 3 on your own. G is the midpoint of FH. FH is represented by 6y minus 2. Find the value of y. So the problem is I don't see any y's here, but I know that this is the midpoint. G is the midpoint. So this segment and this segment have to be congruent, which means I can set up an equation here. You set these equal to each other. That would help you solve for x. Once you have x, then you can plug it back in and figure out how long FH is, and then you could set that equal to 6y minus 2. All right, last set of terms. Angles. An angle is formed by 2 rays with a common endpoint. This is the common endpoint. Ray BA and BC are the 2 rays that form the angle. This is the common endpoint. That's called a vertex. The rays are called sides or legs. I've always heard them referred to as legs, but then I looked this up, and some people call them sides, so we're going to go with either. Two ways to name an angle. We can use 3 letters. The middle letter represents the vertex. So in this picture, I'm going to try to describe this angle. I can describe it by the 3 letters that create that angle. B to O to A. So I'd say angle, B, O, A. You can also go the opposite direction, A, O, B. The order doesn't matter, but the O has to be in the middle because it is the vertex. We go from A to O to B, or B to O to A to create that. We could also just use 1 letter if it's the only letter that's actually, the only angle that's actually corresponding with that letter. This angle, we could say it's ABC. ABC. We could say it's CBA. So we can go that direction, or we could just call it B. There's no other angle associated with B here, so we could just say that's angle B. It's always safest to just use 3 letters, but we can't do the same thing with that top picture. Obviously, if you just said angle O, that could be referring to anything that's on that vertex. So we can't really just say that one. Here we only have the 1 angle, so you could just say angle B. And when we're referring to the measure of an angle, so we would say the measure of angle B, we say M, then the angle symbol, then B, and I would say angle B equals 60. The measure of angle B is 60 degrees. Congruent angles is really similar to congruent segments. If angle A, we're talking about numbers here. If the measure of angle A equals the measure of angle B, then the angles are congruent. This is written as angle A equals angle B. Here we use congruency because we're talking about the angles. Here we use an equal sign because we're talking about the numbers, the literal measure of 75 degrees. Angle addition postulate is really similar to segment addition. We can put two angles together and form a bigger angle. If point D, not angle D, point D is in the interior of ABC, then angle ABD plus angle DBC. ABD is this one. DBC is this one. Together, those create angle ABC. We put those two together to form that bigger angle. Sorry, one thing I wanted to mention about this previous picture, to mark these as congruent, you could put one little arc there and one arc there. That shows that those are the same, or you could put two. The number of little arcs tells us that those two are the same. Angle bisector. Bisector means the same thing that it did before. We're splitting into two sections, an angle that gets split into two congruent parts. A bisector divides an angle into two congruent angles. So in this diagram, ray BD is the bisector. Therefore, we have two congruent angles. This angle and this angle are congruent to each other. That's ABD and DBC. Therefore, ABD is congruent to DBC. All right, perpendicular lines. Two lines that intersect at a right angle. So we could say that these two lines are parallel because they meet at a 90-degree angle. The symbol is an upside down T. So in this diagram, we could say L is perpendicular to M. While I'm describing perpendicular, I think I'm also going to describe parallel, or at least the notation for it. Let's say I make a third line on here. Let's call that N. And say that also meets L at a right angle. Actually, these two lines have to be parallel to each other. So I would say that M is parallel to N. I just wanted to talk about that notation. It's just two lines going straight up and down. You could also say that L is perpendicular to N. Perpendicular bisector is mixing two ideas together. It's going to do both of these two things. It's perpendicular and a bisector. So line, segment, or ray, perpendicular to a segment at its midpoint. So in the diagram, this is the perpendicular bisector. Not this one, because this is not marked as congruent to that. Otherwise, that would be. But these two are marked as congruent. That's the segment that's getting split in half. So LM is the perpendicular bisector to PQ. Because it splits it in half, two congruent segments, and it's perpendicular. It needs to match those two parts. All right, for the most part, you should be able to do okay on this practice. One thing I wanted to clarify, the word classify here means either obtuse, right, acute, or straight. You're just deciding what types of angles we have here. All right, try your best on each of these. If you need any help,